Greetings. Welcome to a little assistance video on problem 5.45, coffee depression and physical activity. Caffeine is the world's most widely used stimulant and approximately 80% is consumed in the form of coffee. Participants in the study investigating the relationship between coffee and consumption and exercise were asked to report the number of hours they spent per week on moderate, brisk walking, etc., and vigorous, strenuous sports, mountain biking, jogging, exercise. Based on these data, the researchers estimated the total hours of metabolic equivalent task per week, a value always greater than 0. The table below gives summary statistics of MET for women in this study based on the amount of coffee consumed. So we have our data here, and what they want us to do is write the hypothesis for evaluating if the average physical activity level varies among different levels of coffee consumption. Okay, so let's get a whiteboard up here so we can do that. So we have two hypotheses. We're going to have the null and we're going to have the alternate. And so how do we go about writing those? Okay, so the null hypothesis, HO, is going to be, well, let's take a look again at our groups here real quick. So what are our groups? We've got mean for less than a cup of coffee per week, mean for 2 cups to 6 cups per week, mean for 1 cup per day, 2 to 3 cups per day, and the person who's got the IV plugged in has got coffee going constantly. Okay, so basically we have what, 1, 2, 3, 4, 5 groups. I'll call those mu sub 1 through mu sub 5 respectively. So the null says is mu 1 is equal to mu 2, which is equal to mu 3, which is equal to mu 4, which is equal to mu 5. The alternate hypotheses, the same for all ANOVAs, which is very nice, is at least one differs. So what they're saying there is at least one of these means is different than the other. Now, one thing to keep in mind is that this hypothesis test is about means. It's about multiple means. What we saw earlier with the independent t-test is that was comparing two means. Now what we're doing is we're comparing multiple means. We have up to k categories or k means that we're working together with here. Okay. All right, so let's go back to the question here. It says check the conditions described and any assumptions we make to proceed with this test. Okay, so there are some assumptions that you have to take a look at for ANOVA. One is that each of the populations is normally distributed approximately. As the sample size increases, that condition becomes less and less stringent. We notice we have really good sample sizes here. They're all very large, so we're not going to have to worry about that condition too much. We have to assume that the samples are independent. We have no cause here to worry about independence. These are obviously less than 10% of the population. It was probably a pretty well done study. And then the last thing we need to assume is that all of the variances among the 5 categories are equal to each other. So that one we're not going to have any way of testing. We're just going to have to roll with that assumption. We'll have to assume that that's true. Okay. All right. So the question I'm really getting asked about why I'm doing this problem is how do I calculate all of these values that go into this table? So one of the things is going back and taking a look at the book is there was a footnote that gave you all of the tools for doing these calculations. So you may have skipped over that. So you're going to make sure you read all of those footnotes. Those are not optional reading. They're actually an integral part of the course, or of the section. So make sure you read those, okay? So in here, a couple of important things that we see is that the mean square group is given by the sum of the squares group divided by the degrees of freedom for the group. And then let's see down here we get the mean square error. The mean square error, that's the mean square within. There's all sorts of different ways of describing those. That's divided by, the sum of the squares of the error divided by the degrees of freedom of the error. Okay, so that's going to be important. We're going to need those in just a wee bit. So we'll come back to those when we need them. All right, so let's go back to our page that we're working on here with the problem. Okay, all right, so let's see if we can get the degrees of freedom first. So the degrees of freedom for coffee is the number of categories. So that's our different levels of the variable. And so the degrees of freedom there is going to be given by k, which is the number of categories, which is 5 minus 1. So that's going to give us back 4 degrees of freedom. Degrees of freedom residual, to calculate that, we've got to take the grand total, which in this case is 50,739, okay? And we're going to subtract from that the number of categories, okay? So that's going to be the 50,739, and we're going to subtract 5 for that because we have 5 categories. I'm going to go ahead and get rid of all that because it actually is kind of in the way. So let's do that over here. So let's go 50,739, and you're going to subtract from that 5, which is your number of categories, okay? And so when you do that, you're going to get 50,734. Okay, and so the total is just the sum of these is going to be what? 50,738 is our total degrees of freedom. Okay, now they just put that in there as kind of a hint to help you out with the next one, which is the sum of the squares. Okay, because what they do, they gave us the total sum of the squares, and they give us the sum of the squares residual, so they're asking us to do a little arithmetic here. We got to take this number, which is the total, and we got to subtract from it this number, which is the sum of the square residuals, to give us the sum of the squares coffee. Okay. So in other words, we got to take 2, 5, 5, 7, 5, 3, 2, 7, and subtract from that 2, 5, 5, 6, 4, 8, 1, 9. And after you get your calculator out and do that, okay, you should get what? 10,508, I think is what I got. All right, cool beans. Now, we need to get the mean squares. Okay, so as a minute ago, I showed you. Let's go ahead and review that real quick. If we get back here, just give me a second. There we go. Oh, okay. So to get the mean square error, we got to take the degrees of freedom and divide that into the sum of the squares error. To get the sum of the squares for the groups, we take the degrees of freedom of the groups and we divide that into that, okay? So with that given, all right, what that tells us, back to our page here, is that what I need to do is come in here, we'll get my calculator out and do a little bit of arithmetic on my calculator because this is something more than I want to attempt to do in my head, okay? And we're going to come in and we're going to take the sum of the squares and divide that by the degrees of freedom. So I'm going to take 105, 0, 8, and we'll divide that by 4. And we get back 2,627, okay? So the mean square, my pencil turned back on here, where'd you go? There you are. So, oops, did two things at once. There we go. Okay, so one more time here. Let's get back to our calculator for just a second here. So we got what, 2,627. So 2,627. Did I get that down right? Let me make sure here. Yeah, okay, cool beans. All right, so we got the calculator here. Let's go and do the next one while we're at it. So the next thing we need to do is take the sum of the squares, which is 2, 5, 5, 6, 4, 8, 1, 9, and divide that by its degrees of freedom, which was 5, 0, 7, 3, 4, okay? And we get back 503.899, okay? So let's go ahead and we'll put it out to 3 places, okay? So if we go out to 3 places, that's going to be 503.899, okay? All right, cool. All right, now what is the corresponding F value? All right, well, the F value is calculated by taking the ratio of these two values. In other words, you take and basically put a division bar right here, and that's going to give you back your F value. So it's the sum of the mean square for the coffee divided by the mean square for the residuals, and we will get back the F statistics. So let's go ahead and do that. Let's get a calculator up here. I'm going to go ahead and move that thing over so we can write while we're at it here. So there we go, slide the calculator over there. Alrighty, so clear out all this craziness, and we're going to take 2,627, and we're going to divide into that 503.899. Okay, and when we do that, the corresponding F statistic we get is 5.213 if we stay with the 3 decimal place idea here, okay? So I'll pen back on here. So that's going to be what? 5.21. If I could just keep numbers in my head for longer than 30 seconds, that'd be great. Okay, 3. All right. All right, cool. Okay, so hopefully that all made sense. It's basically simple arithmetic, not horrible. It's predicated a lot on the fact that you did what? That you read that footnote. If you read the footnote, that it all makes sense. Okay, and then we got a corresponding. They did the FCDF for us, did the corresponding F statistic calculation in the F distribution, which gives us the corresponding p-value. Our p-value is actually really small here. So what is the conclusion of the data? Is that what? We should reject HO. Why is that? Well, because the p-value is very small. We got that our p-value is less than 0.05%, right? Or 0.05, which is 5%. Okay, now, what does that mean? You need to interpret that. Well, what that says is that at least one of the means is different. In other words, that somebody's mean MET, or one of these groups MET, is different than the other ones. There is some nice material in the textbook to talk about how to determine which one of those means is different, but just by looking at them, we might have kind of a guess of which one it is. Here's probably the 2 to 6 cups per week looks to be slightly different, or maybe it's the greater than 4 cups, actually, now I think about it. So now, maybe we should do that analysis, but we don't have all the raw data, which is going to make that difficult to do. Anyway, hopefully that helps. Let me know if you need more help.